So again, just visit this website, Dr. Suhaib, the recording if you want. Now, correlations provide evidence of. What do you think? Correlation provide evidence of association, but not causation, or association that it implies causation. Let's test your knowledge, the basic principles of correlation before we start the lab. Few more seconds and we will shift to the next question. Okay, our next question is coming now. On 3. But here, for example, we got around 50% right and 50% wrong. So guys, correlations provide evidence of association, but no causation. Correlation does not mean causation. This question always comes in the final. I'm really not happy to have half of the students get it wrong. This is not good, guys. This is the simplest principle of correlations, and it is well introduced in the theory lecture that correlation does not mean causation. If two variables are associated together, that not always mean, it is not always the case that A causes B or B causes A. They are just related. Okay? So I'll take this as a note to talk more about this concept. Next. Let's see first who got it right first. Do you follow the screen that I have, guys? So these are who got it right. The 5, is it the 5? 1, 2, 3, 4, 5, yes. The quickest students that got this right. Is this clear, Suhaib, at your screen?
Yes, doctor.
Okay, good. Question number 2. The Pearson's correlation coefficient is always a number between 0 and +1, -1 and 0, -1 and +1, I mean +1, and from -infinity to +infinity. Pearson correlation coefficients. Great. Just few students get it wrong. So correlation coefficients ranges from -1 to +1. And the 0 in the middle means no linear correlation. So the values, it is not like if you choose those who choose -infinity to +infinity, this means that the correlation coefficients can get a value of 5 or 7 or 6 or 900. No, it is from -1 to +1. And 0 means no linear correlation. 0.9 means strong correlation. 0.5 moderate correlation. And -0.9 also, again, it means strong correlation. Okay, I don't want to give more examples now because this will affect the questions of the next run. But let's see who got this first right. Not the same name, right? different names, I think, or the first one is the same. Let's go next. Okay. Pearson correlation coefficients of +1 and -1 indicate perfect association between the variables being tested, true or false. If the R value, when you calculated it or when you run it through the software, it gives you value of +1 or -1. What does this mean? Does it mean perfect association between the two variables? Great. Okay, yes, true. If R equals +1, this means perfect correlation. Any change in A is related to an equal change in B. So perfect line fit, perfect correlation. If the value is 0.9 or 0.8, this means strong correlation. But 1 means perfect correlation. Okay. Great. Good. Our last question. Negative Pearson's correlation coefficient values indicates if you run the correlation analysis and it gives a negative value, this means no relationship between the variables, or this means a cause and effect relationship, or a protective relationship, means that if you apply A, B will not happen, or the correct answer, which is inverse relationship. Yes. So again, those who choose cause and effect relationship and protective relationship, no. As we say, linear correlation coefficients or correlations does not mean causation. So both answer these, the cause and effect relationship and the protective relationship, it's out of the way immediately because we are talking about correlations and correlation does not mean causation. Then negative Pearson correlations means inverse, indirect relationship. When one increases, the other decreases. That's why the R value is negative. No relationship between the variables. If you are running Pearson correlation coefficients and the R value appears to be 0, then you can claim that there is no linear correlation between the two variables. So no relationship, you can claim that when the correlation coefficient is 0. And I'm talking here about the linear relationship and the Pearson correlation coefficients. Because if in the exam, or this is for your future research scope, if the Pearson correlation coefficients appear to be 0, this does not mean there is no association. It means that there is no linear association because there might be another type of relationship between these two variables, but the relationship does not fit a linear line. It is not explained by a linear correlation. It could be a curve relationship, dose response relationship. Okay, guys? So be careful if this, when you read articles or when you think about research or when you're answering your exam questions, 0 Pearson correlation coefficients mean no causation, no relationship. No, this is not true. The correct answer is that 0 Pearson correlation coefficients means no linear correlations between the variables. Okay. Let's see who got it correct and then see first class or okay, third is SS. Okay, so good, congratulations. And we got also number 4 is MZ and number 5, I couldn't read the name. I'll give you just 5 minutes break to pray Asr if you want. And also I will set the Jamovie for our lab. So would you mind, Dr. Sohaib, to maybe switch the recording off for 5 minutes, for example? This is one of the difficult questions that we had in this quiz. So please, from now on, maybe you haven't just revised the material. I know you have an exam next week, so I also run the lab today very fast, so to give you time to go and study for your next exam. But this is an important concept that Pearson correlation coefficients ranges from -1 and +1. I'm worried because a lot of students didn't know the answer, and if you add up those number who did not answer and those who got it wrong, they are more than who got it right. Okay, so it's from -1 to +1, where 0 means no linear correlation. Good. Let's start our lab today. I'm going to share with you the Jamovi file. Okay, let's close this one. Stop sharing. And we'll go to share the Jamovi file. Share. Do you see now the movie file, Dr. Sohail?
Yes, we can see the screen.
Great, great. Okay. Hello again, guys. Let's now start the lab. And please, I'm encouraging you to read the materials of the theory because the final will have more part of Dr. Peter than the one that you took in the midterm. And if you are not well prepared, this will be a very heavy materials for the final. So now perhaps the simplest way of looking at association between variables is with the correlation coefficients, especially the Pearson correlation. Have you covered the parametric and non-parametric correlation, or what did you cover with Dr. Hassan? Can anybody answer this? Are there any responses, Suhaib, or not yet?
There are no responses, Doctor. But Dr. Hassan did go over Spearman and Pearson correlation yesterday.
Both, okay, for parametric and non-parametric. Great. So now talking about the parametric, as I say, the simplest way is looking at association between variables using the Pearson correlation coefficients. When we talk about linear correlation between the variables, and the analysis is following parametric analysis. And Pearson correlation coefficient is abbreviated with as an R, little r. What we are going to learn today is how we can do correlations and correlation matrices and creating the scatter plots to investigate the correlation between variables. So this data that you show now on Jamovi, let me just give you a quick introductory about it. It's well-known data. They call it Big Five personality traits. Very well-known data in the psychology research. Sorry, this is the Kahoot. Let me just close it.
Doctor, is this file on e-learning so they can follow with you?
Pardon?
Is this a data file on Moodle so they can follow with you?
This data file is built in Jamovi itself. It is loaded there. So if you go to here, if you click open, it is there. So data in the library of Jamovi, okay, data library, and you have some data that are available in Jamovi to try and play with it and do several analysis. And this is good for to do your exercises when you're solving my projects or Dr. Peter's projects. So you can open Big Five data from Jamovi. Okay, thank you, Dr. Said. So as I said, this data, just to give you to understand, because before understanding the data set and the variables and what are the rows represent to who subject, with type of subject, people or bacteria or whatever, or monkeys, to understand what to do and how to analyze the data. So now, for example, we are talking about extraversions, openness, agreeableness. The questions, for example, they asked the participants, they had 10 questions to assess the extraversion personality of the participants. And they have another 10 questions to test the openness personality of the participants. And what else? What do we have other than that? Yes, we have the agreeableness. A is, yeah, you have it there. So, for example, questions like they ask the participants to score from 1 to 5. 1 means very inaccurate, and then 2 means moderately inaccurate. 3 means in the middle, he is neither or she is neither accurate or inaccurate. And 4 is moderately accurate, and 5 is very accurate. Okay, very accurate of what? So the statement it comes like this. For the extraversion questions, 10 questions, extraversions, the statement likes, I am the life of the party. And the participants read the statements and say, oh, this is very inaccurate. I am not this type of person. Or yes, I am, this is very accurate. I'll score as 5. I am this type of person. Like,
Or they can come to.
pardon? Okay. So another question from the extraversions criteria are, for example, I don't talk a lot. You can Google this data set and read about it. It's very, very, not very nice research that they get out of it. So, for example, I feel comfortable around people. So if you score 1, this means that this is very inaccurate. It is not my personality. Or if you score 5, this is, yeah, very accurate. I am this type of person. And then they add the scores for each individuals for each questions, and they got the average. Now, let's see here. So let's see the correlation between the scores of, for example, extraversions and openness. So this is subject 1. He answered, look, guys, if you see that the averages of the 10 questions or the 10 statements about extraversions, it was 4.2. So you remember I told you that the scale it was from 1 to 5, and 1 means very inaccurate and 5 means very accurate, when the average means 4.208, the average score for this individual. So he is toward which part of the scale? I need an answer. To the inaccurate part or to the 5, to the accurate part? So he is of an extraversion personality type regarding this individual, and this is the average of the 10 questions about extraversions.
The students are saying accurate in the chat.
Okay. Whereas he is in this trait, which if you like to understand what type of this trait, this means that this person is more what do you call it? He don't talk to people, or he is, just let me give you type of questions that it will be more clear to you when. So I get upset easily. I am relaxed most of the time. I get stressed out easily, or I change my mood a lot. So this participant, he is not of this type of personality. He is more openness, he is more extraversions, okay? Now, let's see if, for example, this variable and this variable correlate, meaning If the person scores high, this reflects another scores, a high score also on the openness. Or if the openness scores are high, this reflects high scores on extraversions. Let's test this scenarios. If you'd like to see more different scenarios, for example, you can have height and weight, and then run correlation analysis. Are taller people have higher weight? So as height goes up, also weight goes up? Or no, when weight goes up, height goes down, then you will have negative relationship. Another scenario, you can test correlations between, for example, studying time and GPA. So more studying time, is it reflected by also higher GPA? Both goes up together or no? It depends. So maybe studying time, but not effectively consuming the time in a good way. So no matter if it's going up, it may affect, you may spend a lot of time, but studying from wrong resources. So your GPA will go down. So in this case, it will be a negative R, okay? And we are talking about linear relationship over here. Now, how to run that on Jamovie. So I'm just giving you different scenarios where you can apply the correlation analysis with. Now, it's very simple in Jamovie. We are almost done now with the lab today. You go to regression and correlation matrix. If you have opened this data on Jamovie, then you can follow me. Now, it will list for you the variables that you have. As you know, this is the place where you'll see your variables. And then I'll choose, as we said, let's test the extraversion with openness. And immediately Jamovie will start to build and give you the answers, because here I'm asking for Pearson, because we are talking about parametric analysis. And then also I told Jamovie to report significance and flag significance correlations. So it will give you that. Here I have, for example, 3 asterisks, which is mean that B value is less than 0.01. I'll go through all of this. Okay, now, but what does this mean? The correlation matrix, and why I have numbers here and I don't have numbers here. Because here, for example, extraversion and extraversion. Please, what do you think the correlation coefficient over here will be instead of the hyphen? If I put the answer here, what should it be? Extraversion and extraversion. If I run the analysis and I put, instead of extraversion and openness, I put extraversion and extraversion, what do you think the answer would be here? Any answer, Suhaib?
So there are 2 people that answered and they said 0.
No. It means 1.
Mariam just answered right now and she said 1.
Pardon?
There are 2 new answers. They say 1 right now.
Yes, it means 1 because you are correlating the same score with itself. So for example, if I show you this, so extraversion, let me see if I can do it quickly here. Transform. Okay, good. Now I just get 2 variables, extraversion 1 and extraversion 2. So it is the same. So if you run correlation, so this is 4.208. This is also 4.208. When this is 3.188, this is also 3.188. So whatever happens here, it also happens here. So this is perfect correlation. Let's run it now. So analyze. And instead of having regression correlation matrix, and I'll choose this time this one and this one. So it is 1 because you are correlating the same variable with with itself. So here, that's why they didn't put it, because it's obvious. That's why they did just hyphen here, because extraversion and extraversion, it will give you 1. like here. So extraversion and extraversion, it will give you 1. But, the software doesn't know that we made it that the same, okay? So also he didn't put extraversion and extraversion 1 here. And he didn't put also extraversion 2 and extraversion 2 as 1 here, okay? Now, what about openness here and extraversion? Why it's empty? It's empty because we have it here. So just to remove the redundancy from the table. So openness and extraversion, or extraversion and openness, this is the value of the correlation coefficient, the Pearson correlation coefficients. It will be the same over here because this is also, again, openness and extraversion, or you can read it as extraversion and openness. So always there is a diagonal line in the correlation matrix. There is a diagonal line where the diagonal is 1. So this could be replaced by 1. If you have another variable, it will be 1 if you are correlating the variable with itself. And there will be a mirror image of the variables between the 2 parts of the correlation matrix. So 0.267 here and also here, because some softwares will put you the complete tables. They will again put 0.267 here. And then you will have a big table full with numbers, but you are concerned only about half of it because it is a mirror image over the diagonal line, whereas the diagonal line has 1s because it reflects correlating each variable with itself. Okay, and I have the B value. So this means that now I would like from you to tell me when I run the analysis, asking the software to give me the correlation coefficient, the Pearson correlation coefficient between openness and extraversion, and it yielded a 0.267. What does this mean? R equals 0.267.
There are 2 students that have answered. They're saying
Yes, please.
Weak positive.
Great. Yes. So the relationship between these 2 variables, according to the data set that we have, it's weak. So there is no good relationship or strong relationship between the 2 variables. Now let's see this on a scatter diagram to look how it looks like. And also I will show you, let's go first with this one. Let's go with this one to ask for plot between extraversion and itself. Look how the line is a perfect fit over the dots. So each dot represents a score of this one and this one, because I have the x-axis, this is the x-axis, and this is the y-axis, and I have each dot so each dot here is represented by a score from the x-axis and another score from the y-axis. So extraversion here is my x-axis, extraversion 2 is my y-axis, and when I have 4.208, so I go here 4.028 somewhere here, I'll go up and put a dot here, and also again it is 4.028 from the y-axis, I'll put it here. And the regression line, the correlation analysis gives a perfect fit that each dot, they follow a straight line because you are correlating the same variable with itself. Perfect fit. Whatever happens to y, it happens to x. Okay? Let's see the 0.2, how it looks like. So this is the correlation matrix for openness and extraversion. Let's ask for the plot. Look how the dots are scattered all over the place. It is not like this one. You see the difference when you have perfect correlation. That means any variability here is reflected with the same variability here between the two variables. But here, no. Variabilities in X is not reflected with the same amount of variability in Y. They have two different variabilities. And that's why the line or the dots, they are not fitting on over the line. They are scattered over the place. But this line means that the software calculated the line where it has the least difference between, or the average. They took the different scenarios from the equation and from the software. They calculated, so for example, if you see this dot here, this dot, if you take the distance from this dot to this line, it is on average the least distance. If you put another line here, maybe it's nearer to this dot, but will be away from another dot over here. So this one, it took this line, I mean, in this place, and I mean with this, the R value, with this R value, this is the best line to fit this data that you have on average. All the data score were taken into account to get the least distance between each data and the line, to get the least distance between each score, each dot and the line. This is what we had. We had a correlation of 0.26, which is a very weak correlation. So variability in Y and X's are not that much. Okay. Now, let me go. I think this will be the last point to give you more time during the weekend to study, to build a correlation matrix between all the variables together. Let's see. So I have extra versions. Let me put this one. And I don't want it one. I want to put it in a new. So we have, keep this as it is, and then we go data, analyze. Oh, sorry, regression, correlation matrix. Okay, so this one and this one. I'll not take this one because it is the same. Take openness, agreeableness, and consciousness. Okay. Look, now this is a bigger correlation matrix because I have more variables here. And where was the, okay, openness, this is openness and extraversion. So here I have it. So openness and extraversion, it is 0.267, the same one that we got it up. But here I put all the variables together. If you are not happy with this variables, I mean this exercise, you may think about HDL, I mean cholesterol level, HDL, LDL, cholesterol level, triglycerides, to see the association. Does higher triglycerides are also associated with higher LDL levels and higher HDL, higher cholesterol level or no? So you can put it this way. So just another example of having all the variables together in the same matrix. So this is again the same R value between openness and extraversion, 0.267, and here we have it, 0.267. But here I have the rest also. It's about, I have openness and neuroticism, and I have agreeableness and extraversion, which is very weak correlation. So variability in agreeableness does not reflect variability in extraversions, and so on. Okay? Any questions till now? And again, this is the diagonal line where it is ones, because it's correlating each variable with itself. And here it's empty because this is the mirror image of this one. This is just the mirror image of this part. Any questions till now? We can get the plot over here also. It will show you a big because it will give you each a plot for each two variables. Look. So this plot is for example, extraversion and openness. So this is extraversion again and openness. So that's why it's empty over here between openness and extraversion. I'm explaining to you how you read the correlation matrix plot. So openness and extraversion, it's empty because I have it here, extraversion and openness. So this is the diagonal line, and this is a mirror image of all these correlations.
Doctor,
So
there's a question.
Yes, sure. Just my last point is that if you look at all the correlation here and the best fitted line, that all of them weak correlations. So in the exam, or if you read an article and you see the plot as this, without even looking at the value of R, you can tell that, okay, this is weak correlation. Look how it's scattered here. Okay, so if we provided you with a diagram in the exam and say to ask you report on the correlation coefficients of this data set. Weak, perfect, strong correlation. What do you think? So if the pictures are similar, it will be weak. And look, guys, you also can judge if it is negative or positive. This one, neuroticism, I don't know how they pronounce it, if I did it right, and extraversion, it is negative. Look, the line is going down. And if I go back now to the coefficient and to check, I'll find it's negative. It's not like this one. This one, it looks like, or this one, openness and extraversion, it looks that it's from here going up. Although it's weak because points are scattered all over the place, but it is positive. It's going from down to up. This one, it's weak, but it's going from up to down. Okay? So higher values in A is related with higher, here you read it like, high, if you are high here, okay, higher values A is related with lower value with X. You see, it is high here and low here. If you imagine that this is the line, actually, this is the line. This one, it should be here. For each plot, this is the y-axis, and the x-axis for this one is here. Okay? So this one, this is the x-axis, and this is the y-axis. So here, higher values on y are related with lower values on x. And when you go to the right, so you are approaching the higher values of x here, higher values of x are related with lower values with y. Let's see the R value now for neuroticism, and I got it right this way, and extraversion. Let's see the R, okay? It is minus 0.35. So from the scatter plot, you can judge or you can conclude the strength of the relationship and the direction. You see, as we say, negative here and positive here. Both are weak, and it shows where it is negative and where it is positive. Yes, please, Dr. Sohaib, you told me that there was a question.
Yeah, there's a question asking, is the one with the p-value of 0.844 the one with strong correlation? Is this correct?
Where is that? Where is this point?
I'm not sure, but the question is basically, is a p-value of 0.844 the one with the strong correlation?
Okay, guys, don't mix between, and this is very important in research, reading articles, in the exam. Don't mix between p-value and the correlation coefficients. P-value doesn't say strong correlation. P-value of 0.8 does not mean strong correlation. the magnitude of the correlation is concluded from the value of R. Let me ask, for example, this one for flag. Okay, let's see here if they run this one. These two variables, openness and conscientiousness, B value is 0.764. Is this strong correlation? No. It's very weak correlation, very weak negative correlation, but it is statistically significant. So statistical significance here means nothing. Statistically insignificant, because this is 0.7. It is bigger than 0.05. So this B value talks only about statistical significance. It doesn't say anything about strong. Thanks for those who asked this question. This is an important point to explain it to the students. Don't mix between the two values here. This one, the R, gives you the strength of the correlation. This one only tells you if this magnitude is statistically significant or no. Here it's bigger than 0.05, so it is not statistically significant. Here it is smaller than 0.05, and even it is smaller than 0.001. The B value for these two variables is smaller than 0.001. Does this mean anything here? I don't think so, because for us it is weak correlation. So it doesn't mean that there is statistically significance when you have weak correlation. If we are talking about medicine, for example, okay, I have an effective treatment and a treatment. I have a treatment, and I run correlation analysis with a prognosis, for example, and it showed weak correlation, but it is very statistical significant. So what? Okay, is this clear? So statistical significance when you have no clinical value means nothing, because the software looks at it only from the numbers point of view, not from the clinical point of view. This will be okay for us to take it into consideration if this is 0.8, 0.679, 0.79. I mean strong correlation and statistically significant. For example, imagine that the treatment and prognosis, strong correlation and statistically significant. Oh, then we are talking. Whereas if I have weak correlation, very weak correlation and statistical significance between the treatment and prognosis. So what is the gain from there? They are not related. It is statistically significant that they are not related. Okay? The other way around, what if it is very strong, I mean 0.9, but not statistically significant? Then you have now a talk here that, okay, is it not because of the sample size? Is it because of the way that we conducted the study? Something wrong? Or really there is just what we are seeing here is just by a chance? And if we took another sample, then we will not get this high correlation, because when we run at this time, we got very large or high p-value. Okay, any question?
Dr. Summer is
done
asking
with the
if
lab. For those who are in hurry to go and study the next for their next exam, it's okay. Feel free. If you have question, please stay with us. I encourage you to stay to hear the answers, because most of the questions will benefit, the answers of these questions will benefit to you also. Yes, go ahead, Suhail.
Yeah, someone is asking if you could please show how to read the last plot again.
Pardon? This
The
one?
last plot, yeah.
Yes, okay. So here, I got this plot because I asked for putting all the variables into consideration. And I asked for Pearson because my data follows the parametric analysis. Next time we'll talk about non-parametric analysis where we get Spearman correlation. So I put the variables here. I asked for Pearson, and also I told what I need. I need the correlation matrix, this one. And if you click flag significant correlation, this is, just by reading the number, you can say this is significant or not. For example, this one, 0.8, it is higher than 0.05, then it is insignificant. Now, if I click flag, this will not be flagged. This one will 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 be flagged. But this one, no. This one, no. This one, no. And here we are talking about statistical significance only, not magnitude of correlation. Magnitude of correlation is here from the Pearson's R. So this is Pearson R. Openness and extraversion. The Pearson R for openness and extraversion, this is Pearson R for openness and extraversion, is 0.267. Small, or I mean, yeah, it's a small number. It's weak correlation. It is statistically significant, but for me now, it doesn't mean anything here. If I'm talking about, in terms of this type of research, they may consider it to create the validity, reliability of the score. No, we are not into these details now. We are just understanding how to read correlation matrix, what the magnitude means. It ranges from -1 to +1. 0 means no linear correlation. Values below 0.5 means, or let's say 0.5 and 0.4, moderate correlation, lower than 0.3, weak correlation, and positive and negative means the direction. So this is direct relationship between the two variables, but it is weak. This is statistical significance. Now, the plot here, it is the same. This one, we are talking about the same variables that I asked to run the correlation matrices between two variables at a run. And this is the x-axis, and this is the y-axis. But instead of putting again x-axis here for this one, and another x-axis here for this one, and another x-axis here for this one, just summarize it this way. If you want to take each one alone, then you can run it this way. You can just ask the program to put extraversion and openness, and you run it, and you take copy and paste this alone, and then change this to, put another 2, run the analysis. It will give you the plot for the other one. Okay, and then you cut and paste this, the second one, and so on. Here, it's all together. Okay. Now, as I said, looking at the dots where it's scattered all over the place, I can say that this is a weak correlation between the two variables. Which two variables I'm talking about here? It is, or there are, the extraversion and neuroticism. Okay, here, this one is extraversion and openness. So this one is exactly the same as this one. Extraversion and openness. Look, for example, for those who didn't get the picture out of this complex diagram here. This is only 2. Extraversion, so it's empty. Extraversion and openness, I have it here. Openness and extraversion, it's empty because I have it here. Openness and itself, it's empty. If I click here and just add another one, neuroticism here, look, the plot will reshape itself and put the new variable in it. So now I have 3 plots. Why? Because one for extraversion and openness, one for extraversion and neuroticism, this one, and one for openness and neuroticism, this one. So when you have 3 variables, you will have, and you run correlation coefficients, you will have a correlation coefficient value for this one and this one. So this is correlation coefficient number 1. And you will have a correlation coefficient value for extraversion and neuroticism. So this is correlation coefficient number 2. And also you will have correlation coefficients between openness and neuroticism, the third correlation coefficient. That's why we have also 3 diagrams. If you put again more, so you will end up with this one, all of them together. So if you, this one, for example, this one, the N and E and O are here. The N and E, this is 1. The N and O, this is the second one, this one here. And the E and O is here. So these, the 3 plots, this one, 1, 2, 3 are here. 1, 2, 3. Okay? And each one alone, I can just go back and remove this one, sorry, and I have each one alone here. Any other question? Again, this is a good example. When you correlate a variable with itself, it will give you perfect correlation. No dots beyond the line. All the dots are on the line. Okay? So variabilities on x's is exactly reflected by the same variable amount of variabilities in y. Okay? Yes, question.
Doctor, there's a question. He's asking on the last slide of the page, why do we have extroversion and both in input and output?
Where is that?
It is which side are you referring to? On the left side.
Which part of the movie we're talking about? Is it this one or is it this one or? Oops, sorry.
Yeah, I think he's referring to the variables when you input the variables, the left part.
The left part. Okay, here, yes. Okay, so I have all the extra. Why 2 extraversions? Is this the question?
I believe so.
Yeah. This was just to explain to you guys that I created this to match exactly this one, just a copy and paste. So if we go back, so this one extraversion, and this is extraversion 2, copy and paste the same values to show you if you run correlation between the variable and itself, it gives you perfect correlation, this one. That's why here I have extraversion. This extraversion, this one, is this one. And extraversion 2 is extraversion 2, is this one. So now here, extraversion and extraversion 2. Here, extraversion and extraversion, it will be the same as this one because these are the same. Okay? That was just an example to show you the difference between perfect relationship and where you have weak relationship, like this one. Where's the plots? I think this, okay, this one, weak relationship. Yes, another question.
Doctor, there's a question asking, Doctor, just by looking at the graph, are we able to tell whether conscientiousness and openness have negative or positive relation? Or will we
Good,
have to go back to the table?
good, good, very good. So when you see it like this, it is very close to zero, guys, but very, thank you for pointing that. When the line is almost horizontal, so it's almost zero, and zero doesn't have negative and plus. That's why. Let's see the R now. Let's see the R. It may be 0.00 something, but it's very near zero. That's why it's not clear if it is negative or positive. It's going up or down. To me, I'm not sure, but I think it's going a little bit down, a little bit going down more than it's not exactly 100% flat and not somehow going a little bit up. Let's see. Maybe I'm wrong. Let's see here. So it's C and O. C, this is C, and this is O. Look, it is negative. But negative one, negative 0.013. So it is almost zero. I think this is the smallest R value. Oh, and we have also O and N. O and N, even smaller. And O and C. Let's see O and N. O and N. This is N and this is O. Again, look. Almost horizontal line. Almost horizontal line. This one and this one. But thanks for pointing this out. It will help a lot of students to understand these scenarios. Any other question, guys?
Guys, do you have any other questions? I guess that's it, Doctor.
No more questions, Fouad?
No, I think that's it.
Okay, good luck, Shabab, with your next exam. I know maybe it's not a good time to give you a lab on biostatistics when you are a little bit, but you will do good, inshallah. Good luck. And if you have any questions, you are more than welcome to ask me. Thank you, Dr. Suhaib, for taking care with this session.
Thank you, Dr. Fouad.